Hi and welcome to another episode of McClutchy Maths. My name is Natalie McClutchy and today I'm taking you through part 2 of a series on surface area, focusing on cylinders. This is suitable for grades 9 and 10, grade 12 Essential Maths for Unit 3 and Year 11 General Maths for Unit 1. You can reach me as always at mcclutchymaths@yahoo.com if you have any questions or would like to request a particular video. Let's get started. Firstly, let's think about what a cylinder is. It's a three-dimensional shape consisting of a circular but flat top and bottom and a curved wall. And here are some examples from real life. Drink bottles, water tanks, cans of soft drink, silos and pipes. Now, one of the things to think about in these particular examples, that water tank there does not have a flat top and bottom. So we're really technically not a cylinder, but you get the idea. If we were to draw it as a net, we would see two circles and a rectangle. Now this is important to think about a cylinder in terms of a net. Firstly, you're going to be adding the area of two circles together, and the formula for area of a circle is pi r squared. We don't use a diameter, we use a radius. And then to develop the rectangle, which makes the curved surface of the cylinder, we're making that made of the height, which is usually given, and then 2 pi r is the circumference of the circle because that rectangle wraps around the circle, and when we fold that out it becomes a rectangle. So that other length that we get there is 2 pi r. Some common mistakes that students will make when they're calculating the surface area of a cylinder are as follows. Firstly, they mistake the diameter for the radius. It's really important when you look at an example that you're given that you check to make sure that you've got all the information you need to get started. And one of those vital pieces of information is your radius. In the formula for cylinder, there is nothing about a diameter. So if you're given a diameter, make sure you convert it. The second common mistake is getting those formulas for area and circumference back to front. A lot of students I see will sometimes, instead of finding the area of the circles, they'll find the circumference of the circles and add that to the rectangle's surface area as well. And that's a big no-no. Or they'll do the opposite. They'll find the area of the circles and then they'll apply that area to the side of length of the rectangle, and instead of the actual circumference, which is the part that wraps out to make that rectangle. And another common problem that people will make is including a face in practical problems. So for example, if we were to paint a water tank, we wouldn't need to paint the base because that sits on the ground. So that's a face we get to ignore. And students will include that face by accident simply by using a formula by rote. So really you need to approach all questions with surface area with a thinking mind and think about what's going on and read your question properly. Let's do some looking at our key formula for the surface area of a cylinder. The formula is the 2 pi r squared. That's your two circles times by the area of those circles plus 2 times pi r h. So 2 pi r is your formula for your circumference, which makes that length times the height of the cylinder. We can simplify that by taking the highest common factor out the front, which is 2 pi r. Now, I personally like this formula a little bit better. It means I'm not having to square anything, and it means I can do some fairly simple calculations on my calculator. So this is the formula I'll be using throughout this presentation when I give you the 3 worked examples, which are coming up now. Here's worked example 1. This is what I would consider to be a simple familiar question, finding the total surface area of a cylinder shown. I'm asked to give that as an exact answer and to 2 decimal places. So following the Polya C-Plan Do Check process, first of all, I'm going to look at this diagram and I'm going to decide if there's anything on that diagram that I need to annotate. For example, a diameter that might need to be converted to a radius, or if I've got 2 units of measurement, maybe centimeters and meters, and I might need to convert to one kind. So looking at this, I can see that they're both in meters and that I'm given the radius. That's wonderful. Part of my planning process now is to label the diagram with r the radius and h the height. This will make it very simple for me to substitute into the formula. My next step is to write the formula. TSA equals 2 pi r multiplied by r plus h, and then substitute the information directly from the diagram into the formula. Everywhere I see the letter R, I'm going to put the number 5, and everywhere I see the letter H, I'm going to put the number 25. Now I'm going to use my brain, not my calculator, as much as I possibly can, and I'm going to simplify this a little bit further. 2 times 5 is 10. Notice when I did that second step of working that I put it in brackets, simply because there's lots of parts going on there and I don't want to simply multiply the radius by what's in the brackets. I want to multiply 2 pi r by what's in the brackets. So I'll put that in brackets to remind me that the whole thing is being multiplied. I've simplified that to 10 pi. Inside the brackets I have 5 plus 25. I've simplified that now to 30. I can simplify even further. 30 by 10 gives me 300 pi. I was asked to give this as an exact answer and to 2 decimal places. As an exact answer, it's just 300 pi. I don't multiply by pi on my calculator because that would not be exact. It would be rounded to maybe 10 or 15 decimal places. My next step now for my final answer is to do that. I'm going to put it in my calculator and I'm going to find that the total surface area of this cylinder is 942.48 meters squared to 2 decimal places. So a bit of rounding there. My very last step is I'm going to write a statement and I'm going to check that I've used the right units of measurement and that I've written them down. I'm not going to write meters cubed because I'm not finding volume. I'm finding surface area. Let's look at something more complex now. Worked example 2 is a half cylinder. So using my formula is not going to work exactly because this time I don't have 2 circles. I've got 2 semicircles. I have half of a curved area and I have a rectangular base that I need to consider in my surface area this time. So as part of my seeing process, I'm going to look and see what information I'm given. Both of them are in centimetres, that's good, no conversions to make. But I've been given a diameter, not a radius, and I need to convert that because I don't use the diameter to work out circumferences or areas of circles. So part of my planning is going to be to annotate this diagram. I'm going to put h for the height. I'm going to label the diameter. I'm also going to convert that diameter to a radius of 2. Now I can simply rewrite this formula and I'm using words to describe what I'm doing here. I've got 2 semicircles, a base and half of a rolled side. Now I'm going to make this into a formula by developing it a bit more using some letters that I've got from my diagram. I've got 2 times a half a circle's area, that's why it's half pi r squared, plus d, that diameter multiplied by the height, which is going to be that area of my rectangular base, plus a half of the 2 pi RH. Now ordinarily if I had a whole cylinder and I flattened that out, I'd have a rectangle, which I've got here, but I've only got half the rectangle and that's why I'm multiplying it by half because it's a half cylinder. Let's now substitute some information that we've got into the formula. Everywhere I see the letter R, I'm going to replace that with the number 2. Every time I see the D, I'm going to replace that with 4 and H with an 8, and that's what I've done in this particular line of working. My next step is to simplify that line of working. I'm not going to plug it straight into the calculator and give a final answer. It's always important to show your steps. So half of 2 gives 1. 2 squared is 4. So 1 times 4 I've written there. 4 times 8 is 32. And then I've got half of 2, which is 1, and 2 times 8, which is 16. So I'm simplifying this a little bit further. Now I'm going to collect my like terms. I've got 4 pi at the beginning and 16 pi at the end. That makes 20 pi altogether, plus 32 centimetres squared. Now this is an exact answer. If I was to put it in my calculator, I would end up with a rounded answer. So I'm giving it exactly as I'm asked in the question. And this is where I go back and check. I check to make sure I've got the right units at the end. I check that I've actually answered the way I've been asked to answer. And I check that I have a logical answer as well. Worked example 3 is a little bit more complex again. Now in this particular example, I've got a concrete pipe and it's shown to be painted on the outside only, and that includes a lip shown by T. The dimensions are 30 millimeters, D equals 18 and L is 27. And I'm going to find the total surface area that I need to be painted. So first of all, I'm going to annotate that diagram. Okay, so this time I've got the diameter of that inside part of the pipe. Now I'm not going to be painting that, that's just pure air. So that diameter needs to be converted to 9 centimetres, which is my radius. That's the part I'm going to use in the formula. T is given in millimetres. It's 30 millimetres, so I've changed that to 3 millimetres in this particular example. And then I've labelled L. Another thing I should label as well is the whole of the diameter of the whole pipe. That includes the hole in the middle plus the lip at the top and bottom, 3 and 3. So my full diameter of that full pipe is 24. So that means down the track my radius will be 12. So now I'm going to rewrite this as a formula. I've got 2 pi r plus h. That's going to be giving me the full surface area of that big pipe, including the center. But then I want to take that center out, which is going to be those 2 smaller open circles. And then I need to do 2 pi r plus h minus 2 pi r squared. So I'm actually going to substitute in some of the variables from my equation. Now I'm going to substitute the information I'm given. So work with me here on the third line of working. 2 pi times 12. Now you might ask, where did the 12 come from? You can't see the 12 on the diagram. Well, that's the radius, remember. That's half of that full height of 24. And then the brackets, the 12 plus the 27. So in this first part of this equation, we're actually working out the total surface area of the whole pipe with the tops included. And now we need to take off the top part, those holes. 2 pi times 9 squared, which is that radius of that little circle in the middle. Now we can simplify that further. 2 times 12 is 24 pi. Inside the brackets, 12 plus 27 is 39. And then I have 9 squared, which is 81, times 2. And then times by pi. Simplifying that a little further again, 24 times 9, I'm going to need my calculator for that one, is 936 pi. Take away 2 times 81 is 162 pi, is 774 pi. Now I come back to my question. I wasn't asked to give this in an exact value, so I've given it as an exact value there, but now I'm going to convert it into a real number. It's 2,431.59 centimetres squared. The total area to be painted is a statement, 2,431.59 centimetres squared. Well, that's all we have time for today on our total surface area part 2, cylinders. I hope you found that interesting and valuable. Have a great day.